Hello, my name is Chris Cadena, and today we are going to be looking at Newton's third law of motion, which states that for every action there is an equal and opposite reaction. So we're going to see an example of this in the real world. So the example I will be showing today is based off of two rolling chairs, which should accurately show the forces that are achieved as a result of one of the chairs pushing onto the other, which we will see in just a second. As you can see here, I'm sitting next to my friend Arya, so that when I push him, you should not only see a force onto his chair, but a force onto mine as well. So let's see. And there we both have movement after the force is applied. Now, let's try this example in the notebook to see if it holds up. So, the law states that both forces should have an equal and opposite reaction. So, the force of Chris, myself, should be equal to the force of my friend Arya. And in order to see if this is true, we can use the equation force equals mass times acceleration to prove it. So, now that we have established this equation, which is one of the fundamental laws of physics, we can start to manipulate it using what we know. So, the mass of myself is around 65 kilograms, and the mass of Arya is around 50 kilograms. So, since we know these masses, we can find the acceleration of both, assuming that the forces are equal. And if our results match the video, then the forces are likely equal. So, we can say force 1 equals force 2, because that is what the law states. And we can begin to work this problem. So, force 1 equals mass, which in my case is 65 kilograms, times acceleration, which we were trying to observe. And then the other force will be 50 kilograms times acceleration. Now, using these equations, we can directly compare the accelerations of both of us. So, acceleration of Chris, myself, is equal to force 1 times 65 kilograms. And the acceleration of Arya, my friend, is F2 times 50 kilograms. Now, using these new equations, we can directly compare the accelerations by using the ratios of the weights, because we know, or we're trying to prove, that the forces are equal for both. So, 50 over 65, we can find what percent of 65 is 50 by comparing it to x over 10, which will find the missing variable. So we can cross multiply, so we will get 5,000 equals 65x, and then dividing both sides by 65 will show us that 5,000 over 65 is equal to the percentage. So if we get out our calculator, we can see what that is. So 5,000 divided by 65 is equal to approximately 76%. So 50 is approximately 77% of 100 would be rounded to. So we know that x is equal to 77%, which shows that 65 is 33% greater than 50, which means that since Arya had less weight, his acceleration should be 33% greater than the acceleration of myself. So we can go back and observe the video to see if that is the case. So if we look here at a similar push, we should be able to see both forces occurring. And like we said earlier, if the forces are the same, then Arya's acceleration should be greater than mine. And as you can see here, his acceleration is much greater as he travels a further distance faster. So this suggests that the equation done before is correct, and also suggests that the forces do have an equal and opposite reaction.